contributes to a low carbon economy because we use hydrogen from water, and that hydrogen contains a lot of energy which otherwise would come from carbon. So in making methanol from sustainable hydrogen, we save using fossil fuels. And in the end, we have a demonstrator plant producing 500 tons of methanol per year, which is, it's small compared with the full industrial scale, but 500 tons of methanol is a lot. So for a project like this, I think we've done very well in that respect.
I believe for the industry, and especially for the energy industry, it's a very important project because it's able to demonstrate that we are able to close in some way the carbon cycle. And now in the next project, we will apply this life cycle analysis methodology to other combinations, not with perhaps a coal-fired power plant, but with a waste incineration plant or with a biomass plant.
We are now able to synthesize better catalysts for special niche applications, which can be used then in various settings, like in power plants, for ferries and stuff like that. I'd say that the main result is that we've perfected the understanding of the reaction, and now we have an understanding that allows us to model this from atom scale to the process scale, and this knowledge is actually transferable, so we can use this tool set for other reactions as well, not just this particular case.
It is possible to increase the renewable sources exploitation and the power plant flexibility, reducing the overall global CO2 emission. We are also taking data from the real operating system, testing and validate our theoretical studies.
This basically allows us to couple sectors together, to use both the energy sector, the manufacturing sector, and then, of course, the mobility sector together in an entirely new way. It is, of course, very important for us to both show that this technology works at larger scales, because larger scale means usually better economies in terms of production costs and also erection costs of building the plants, and to be fully commercial.
A technology like MefCO2 can help us in two ways. On the one hand, MefCO2 could serve as a chemical long-term storage for renewable energy, and on the other hand, we can use CO2 from the plants as a carbon source for creating e-fuels. The next step, we are looking forward to a bigger plant at a demonstration scale, so we have joined forces together with our partners, and we are now planning these steps, and we're looking forward to get some funding for this second step project.
And this will help in the long term to bridge the old world, which is the fossil world, with the new world, with the renewables, and give also opportunities for many new business cases. The results of this project are to get a deeper view how to engineer and to integrate such a technology into existing infrastructure, to get results about the operation of such a plant integrated in an existing energy system, and to collaborate in a fruitful way in an international group of partners and peoples from so many different European countries. That was a challenge, but also a great opportunity for us.
It gave us the opportunity to develop a new product, a dual cell stack, plug-and-play containerized highlighter solution with a capacity of 1 to 2.5 megawatt. And that is a product that we will bring to the market now, and where we can see the demand increasing steadily for hydrogen refueling stations. We want to take the product that we have developed here and double the capacity without increasing the footprint. So the next step is to develop a product with the same footprint and a capacity of 2.5 to 5 megawatt, which we can then use as a building block to go up to plants of plus 25 megawatt.
Well, I think we are setting the base for a future in which we have a more decarbonized economy. This is not a final solution. We are just testing how this technology will look like in the near future. So for me, it's just a starting point in which we have learned how to integrate different contributions and technologies from different players. But my goal would be just to find out a demonstration project larger than this one, if we will show that it works. So in this case, we will be showing that this is clearly a mitigation factor in the transition to a low carbon economy. This is the main goal, the main mission we have now in mind.